Good morning, everyone. All right, let's get started. Today, we're going to dive into one of the most elegant and, frankly, one of the most powerful tools you'll encounter in managerial economics and operations research. It's called the Lagrange multiplier method. Now, I know the name sounds a little intimidating, maybe a bit abstract, but stick with me, because what this method really does is give you a systematic way to solve a problem you will face literally every single day of your careers. How do you make the best possible decision when you don't have unlimited resources? It's really the mathematical key to getting the absolute most out of the least. At the end of the day, almost every single strategic business decision boils down to this one question. This is the heart of what we call constrained optimization. You're always asking yourself, what is the absolute best outcome we can possibly achieve with the resources we actually have? It doesn't matter if you're a marketing manager with a set advertising budget, a production supervisor with a limited supply of raw materials, or a CEO with a finite number of staff hours. This is the fundamental question you have to answer to be successful. And this leads us to what I like to call the fundamental business puzzle. You see, every single organization, I don't care if it's a tiny startup in a garage or a massive multinational corporation, has to figure out how to reconcile its big goals with its day-to-day realities. The real challenge is finding that sweet spot, that perfect alignment between your ambitions, like, say, launching a brand new product, and the very real limits on your money, your people, and your materials. Now, this table here, this visualizes that puzzle perfectly. It's all a balancing act. On the left, you've got what we formally call the objective function. That's just a fancy term for your goal, the thing you want to maximize. It could be profit, it could be how many units you produce, or maybe it's your market share. And then on the right, you have your constraints. These are the rules of the game, the real-world limits you can't exceed. A budget is a classic constraint. So is a limited supply of materials or the number of hours your team can work. The entire game of business strategy is finding the point where that objective on the left is as high as it can possibly be without breaking any of the rules on the right. Okay, so faced with all this complexity, how do you actually solve this puzzle? How do you navigate from this tangled web of possibilities to find that one single optimal solution? I mean, in a really simple scenario, you might be able to use your intuition, right? A good gut feeling might get you close. But what happens when you're in a real business with dozens of variables and multiple complex constraints? Relying on a guess is not just inefficient, it's incredibly risky. We need a structured, a rigorous way to prove that we found the best possible answer, not just a good enough one. And that structured, rigorous way, that's the Lagrangian multiplier method. This is the tool for the job. What it does, and this is the beautiful part, is it transforms that whole balancing act, that messy problem of weighing your goals against your limits, into a single, solvable algebraic equation. It gives us the formal structure we need to pinpoint the exact combination of inputs that will give us the maximum possible output, all while staying within our restrictions. So let's look at the formal definition for a moment. The Lagrange multiplier method is a technique used to find the maximum or minimum of a function subject to constraints. Let's break that down because every word there matters. The function is our goal, our profit equation, for example. The constraints are those boundaries, those fences we talked about that we're not allowed to cross, like our budget. So think about it this way. This method doesn't just find the highest mountain peak on the entire map. No, it finds the highest point you're allowed to climb to while staying inside the fence of the park. That's a crucial distinction. Conceptually, the logic is actually pretty straightforward. Step 1, you have to define your goal. You do this by writing down your objective function, which we'll call f of xy for now. Step 2, you identify your limits. You write out your constraint equation, maybe something like g of xy equals c. Now, step 3, this is where the magic really happens. We don't just sort of guess and check to find the optimum. No, we build a new function, and this is important. It's called the Lagrangian. This new function cleverly combines our goal and our limit into one single equation. The optimal solution is then found by analyzing this new Lagrangian function. All right, so we have the abstract framework down. We have the math. But now we have to ask the most important question you should ask in any business class. What does this actually mean for the real world? Why are we spending our time on this 18th century mathematical technique in a modern business course? How does this theory translate into actual, tangible value for you as a future manager or analyst? Well, the application is incredibly direct and powerful. As our source material points out, this method is basically custom-built for business optimization problems. Here's a classic example. Imagine your company produces two different products, product A and product B. You want to figure out the exact number of each to produce to make the most profit. But you're constrained. You only have so many machine hours available in a day, and you only have a finite amount of raw material. This scenario is a textbook Lagrange multiplier problem. This quote right here really gets to the heart of its value. But here's the kicker, and this is what makes the method so incredibly insightful. The method gives you more than just the answer for maximum profit. You see, the multiplier in the name, it's a variable we introduce, usually the Greek letter lambda. That little variable has a profound economic meaning. It actually tells you the shadow price of your constraint. In other words, it quantifies exactly how much your profit would go up if you could get just one more dollar for your budget or one more hour of labor. That's not just an answer. That's powerful strategic intelligence. So just to recap, let's think about these two core components. You have the function. That's your goal. You can picture it like a topographical map with all these contour lines, where each line represents a certain level of profit. Higher lines mean more profit. Then you have the constraints, which you can picture as a boundary line drawn on that map. The Lagrange method mathematically finds the exact spot where the highest possible profit contour line just kisses the edge of your boundary. That single point of tangency, that's your optimal solution. In the end, the value of learning this method is so much bigger than just being able to do the calculation. It really gives you a rigorous framework for strategic thinking. The process itself, the act of setting up the Lagrangian, forces you to clearly define your objectives and precisely quantify your limitations. Just that process of translating a messy, real-world business problem into a clean, quantitative model, that alone is one of the most valuable skills you're going to develop in your entire business education. And that leaves us with a final, really strategic question to think about. Instead of seeing your constraints, your budget, your resources, as just frustrating limitations, this method allows you to see them as levers, as opportunities. By understanding the shadow price, by knowing the value of relaxing a constraint, you can make incredibly smart decisions. Where should you invest your next dollar for the highest return? Should you increase the marketing budget, or should you try to source more raw materials? The Lagrange multiplier method doesn't just give you an answer for today. It gives you a roadmap for how to unlock future growth.